Welcome to another video by Team Matcom. In this particular video, we will be discussing a question that is from the chapter Motion, Laws of Motion, as well as connecting with the chapter Work Energy Power. The question is, a boy pulls a 5 kilogram block of 10 meter along a horizontal surface at a constant speed by a force directed 45 degree above the horizontal. If the coefficient of kinetic friction is 0.2, how much work does the boy do on the block? So basically they have given you the coefficient of kinetic friction mu k is equal to zero point 0.2. They're telling that acceleration due to gravity can be taken as 10 meter per second square. The mass of the object is given as 5 kilogram, 5 kilogram. And we are like what I can say, displacing the object along the horizontal direction by 10 meter. So displacement along the horizontal direction is 10 meter. The force is applied at an angle of 45 degree. By keeping all these things, you can make it as we have a block. That particular block is having a 5 kilogram of weight. So as a result, there will be, so the weight that will be equal to W, that will be equal to mass into acceleration due to gravity, that is equal to 5 into 10, that is equal to 50 Newton. 50 Newton. Now we are applying a force of a constant, a force is applied at an angle of 45 degree above the horizontal. So this is going to be the horizontal. With respect to the horizontal, we are applying a force F at an angle of 45 degree. At an angle of 45 degree. So at an angle of 45 degree. So this is what they have given. So if a force is applied, we know that there is a, like what I can say, the friction component also will be there. So now, since this particular force is applied at an angle of 45 degree with respect to the horizontal, this particular force can be resolved into two components, Fx component and Fy component. Therefore, Fx that will be equal to F cos 45, because horizontal component is nothing but the cosine component, that is equal to F into cos 45 is 1 by root 2. So that is equal to F by root 2. In the same way, if you take the vertical component, that will be equal to Fy. So Fy will be equal to F sine 45, F sine 45, that is equal to F into 1 by root 2. That is also nothing but equal to F by root 2. That is equal to F by root 2. We know that the Y component of the force as well as the mg, they are acting in opposite direction to each other. Therefore, R, the normal reaction R will be is equal to mg minus Fy, mg minus Fy, that is nothing but equal to 50 minus F by root 2. 50 minus F by root 2. See, we know we need to find out work done along the x-axis. We need to find out the what is the work done on the horizontal block, on the block when it is moved at a distance of 10 meter around the horizontal. So if you're considering the Fx component, so there will be having the component of force, the component that is associated with the kinetic friction, that is Fk. We know that the Fk is equal to coefficient of friction into normal reaction, that is equal to mu k into what is R? R is 50 minus F by root 2. We know that this particular applied force, the force that is applied, which is acting along the x-axis, as well as the Fk will be acting in the opposite direction, which will be acting in the opposite, because you can see that this is the kinetic friction component. If it is acting in this direction, mean applied force component will be in this particular direction. So if Fx and the Fk will be opposite to each other, therefore Fk can be replaced by Fx. So what we can write? We can write it as F by root 2, that is equal to what is mu k? Mu k is 0.2 into 50 minus F by root 2. If you open up the bracket, you will get 50 into 0.2. 50 into 0.2 will give you 10 minus 0.2 into F by root 2. So if you take the component which is containing F together, what we can write? We can write it as F by root 2 plus 0.2 F by root 2. 0.2 F by root 2. So that is equal to 10. So the denominator is same. So we can write it as F plus 0.2 F divided by root 2 equal to 10, or so we can take it to the other side. What you will be having? F plus 0.2 F, that is equal to 10 into root 2, 10 into root 2, that is equal to 10 into root 2. So that will be equal to what? That will be equal to 10 into 1.414, that is 14.14. Therefore, f plus point root equal to 1.2 f, that is equal to 14.14. Therefore, f is equal to 14.14 divided by 1.2. So when you divide 14.14 divided by 1.2 will give you 11.78 Newton. What is this? The value of the applied force. Now we need to find out the work done. So we have a displacement along the horizontal direction. So work done is equal to the component of force along the x direction multiplied with the displacement. They're telling that it is displaced by 10 meter into 10. So what is Fx? Fx is equal to F cos 45. F cos 45. That is F value is 11.78 divided by root 2. So this will become 11.78 divided by root 2 into 10. So into 10 divided by root 2 will give you, divided by root 2 will give you 83.32. 83.32 joules. So this is the work done whenever there is a displacement along the x-axis by a distance of 10 meter when we are applying a force F at an angle of 45 degree with the horizontal. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.